So everybody, hi and welcome to this. So this is our first Catalyst Network developer community virtual meetup. Now, I don't know where everybody's from, but thank you for dialing in, especially those in the Americas and those in Asia. I know in Asia it must be very late now. So, thank you for taking the time. So I'm Darren, I'm one of the co-founders of Atlas City, and I'm the Chief Executive Officer of Atlas City as well, which as a result makes me a very passionate supporter of the Catalyst Network. So we're hoping to run these meetups very regularly, hopefully weekly or fortnightly, but it's really going to be about putting these as often as it's needed for the community, because we just want to get the community to be as productive as possible. So this is really more about the developer community. So it's really about the Catalyst developer community. It's about dialogue. It's about putting faces to names, answering questions, discussing new ideas. And as a software developer myself, I know the importance of whiteboarding and just being able to talk through ideas and share ideas with my peers. That's one thing which has frustrated me in some projects in the past. It can be very difficult to actually find people in the core community to be able to talk to. So this is something we're working very hard to try and get right for Catalyst from the very beginning. So that's what this is all about, really. It's about collaboration through a regular meeting discussion. So this is really for developers, whether you're a developer who wants to get involved in the core code technologies. So core developers, we've developed an awful lot up till now. We're preparing to open source, so you'll hopefully all get to see just how much we've accomplished over the past 2 years. But there's an awful lot to do. We have a very ambitious roadmap, so hopefully that people will find areas they want to get involved and areas which will excite them. But it's also about developers who want to build dApps and services on-chain and off-chain. So whether you're building wallets, even hardware devices, whatever it is you want to build, hopefully you'll find some benefit from the Catalyst network. So we want to really make it so it's suitable for everybody. I'm a .NET guy myself, so I'm used to working in Visual Studio and those kind of tools. So we really want to get the tooling right for professional engineers, Java developers, Python developers, .NET developers, right through to the pure hacking community, the people who really want to get involved in more of the computer science side of things. So Catalyst is really a project ultimately about enabling Web3 for me. So I come at this looking at sort of web services, microservices, web applications. And I think what we're trying to build with Catalyst is a full technology stack to enable these kind of services, but in a more decentralized way. You'll notice maybe on my shirt, I'm a member of EFF, I'm a bit of a privacy advocate, and so like many people, I really value privacy and being able to build applications which serve real businesses and consumers, but without all the compromises which are going on today in, we read about social media and many of the bad things which are going on. So we're trying to build that community technology stack to enable good applications and good practices, but in a more respectful way. So this is a great opportunity as we come together, share ideas, and just really make this all about what you guys need it to be. So before I waffle on too long, because I'll hand you over to our lead, our head of engineering, James Kirby, who can talk much more about the technology itself.
Cool. Thanks, Darren, for that. So yeah, Darren, just give a bit of an introduction to how we got into where we are now. So yeah, I'm James. I'm the head of engineering at Atlas City, and I'm also the lead of the Catalyst Network project. So I've been working here for about over a year now, and working on this new core protocol. Not just me alone. We've got a bunch of other developers. Some of them are online with us. And what we're going to do today, we're going to kind of just go through the kind of ideas that accumulated into building Catalyst Network, and then go through some of the core architecture, some of the architecture of the node and the network. And then as well, if we've got time, we'll try and have a look through some of the code, so people know where it is and how to get started using it. So Okay, let's have a look who we've got. I think Thomas has been able to join us. Right, so what is the Catalyst Network? Catalyst Network is, like I said a minute ago, a new core protocol, but we've designed to be scalable. Well, we designed it to solve the blockchain trilemma. That was the kind of the initial idea when we were starting out here. But we wanted to build something that was scalable, that had scalability, security, and decentralization. So that was the accumulation of all the design rationales, the problem that we wanted to solve. In the blockchain space. But on the developer side, what we wanted to also do was lower that barrier of entry to actually being able to contribute to the core protocol development. So, things like Bitcoin, you have to be a super C++ developer to even think about trying to understand some of that code and where to start making patches. And then even then, but it's such a closed, small, ring of people who actually then look after that code and are the ultimate gatekeepers into what goes into there, that my feeling always was that it like blocked you out from wanting to contribute to these kind of projects. So what we wanted to try and do was have a low barrier of entry for developers. I mean, you still got to obviously be able to do good code, and the ideas have still got to go into what we want to do, but we want to allow people the flexibility to feel like they're contributing to this project. And the way we kind of architecture the system kind of goes around that philosophy and that rationale. So, we made the system very modular, so it's very tightly packaged up little compartments of functionality. So, you can really get stuck in one area and, become an expert in that one area, abstracted away from the rest of the code base. And this idea of modularity was also, to try and aid the actual adoption of the Catalyst network. So, again, if you want to go into use like Bitcoin or Ethereum, that you'd have to go and use a very specific code base, and you'd have to use all of it and all the bells and whistles, and there's not really that much there for you to be able to, pick and choose what kind of technologies you want to use out of these, blockchain distributed systems. So again, that was a kind of idea we wanted to try and influence through the development of this code base, to have this modular architecture that really aided people's adoption of the protocol and of the project. So you might want to leverage some aspects of the Catalyst network. You might not be able to use all of it for your project or your business use case, but being able to use parts of it and slowly transition into these kind of distributed systems, we think again lowers that barrier to adoption and to entry into the blockchain world. So the Catalyst network is consisted as a project of different, what we call modules, or services, shall I say. So the Catalyst network is not just a single blockchain for just doing, cryptocurrency payments. The idea is that we wanted to try and introduce different kind of distributed protocols into one network. So if you think about all the projects that are out there, they all try and do something. They are trying to do file storage, they are trying to do contracts, trying to do payments, try and do one specific thing. And if you want to try and build or use all of these technologies, or mix and match these technologies into what you're doing, you then have to learn 5 different stacks, 5 different languages, 5 different ways of doing things. So what we tried to want to do was trying to not just take bits of technology, but what we want to try and make a fully serviced and full encompassing network and a broad spectrum of services to actually use on this one protocol and on this one network. So yeah, the Catalyst networks may comprise of a new consensus algorithm that we've been working on, which we call probabilistic BFT consensus. We'll talk about a little bit more, we'll go into a bit more detail about that later on. Catalyst network also has DFS. So DFS is a distributed file system. All the nodes on the network contribute some space to the network, and this space is used to store the global ledger state or the global state of the network. And what the DFS can also be used for is Additional things we're going to be building into the DFS are stuff like a DFS marketplace. So that will allow people to buy and sell storage space on the network. Yeah. So next service that we're kind of building into the Catalyst network is this idea of a distributed compute system. So one thing that we found that was limiting in previous generation of blockchains like Ethereum smart contract languages was that while it was like a revolutionary or a technological breakthrough, that the functionality was still quite limited in what you could actually do with it. So we wanted to have the ability to some sounds. Sorry, I get some sound from someone. Okay, yeah. So we was talking about smart contracts, but yeah, some of these previous generation projects, they had quite limited functionality in what you can do in the smart contract systems. So what we wanted to try and introduce was the idea of complex logic that could be executed in a kind of smart contract fashion and achieve consensus. So we've been working on this idea and designing this idea of a distributed compute system where people can do a lot more complicated and complex, longer standing computations on the blockchain network or on the protocol, and feed that into a consensus mechanism and have it stored in the single source of truth of the ledger. Next is Catalyst Network also will feature a distributed DNS system. That distributed DNS will be able to register domain names on the ledger, and them domain names themselves can link to any type of content. So not just linking to a website. It could link to a payment address. It could link to a file. It could link to a video. So yeah, and that's using a technology called DNS Link. And that will be integrated quite closely with DFS file systems. So essentially what you'd be able to do is use that to actually host distributed websites. The next big service, which features in the Catalyst network, is the KVM smart contracts. KVM smart contracts are kind of, I guess, what the Ethereum community wish EVM could be. So KVM is an extension of EVM, and we're working with a project called Nevermind. I was just seeing if he's online. He's not managed to make it on, but yeah, we're working with a project called Nevermind, which is a .NET Ethereum client, which are based in London. We're working with them to do a port of EVM from their code base into the Catalyst network. And what that KVM will be is will be compliant with the existing EVM standards or the ERC standards, but also what the KVM will do it will add extra functionality, predominantly over these different services on the Catalyst network. So smart contracts will be able to hook into the DNS, the compute system, the file storage. Yeah, them services, as well as additional pre-compiles. Then pre-compiles can hook into some additional functionality that Catalyst Network offers, such as bulletproof cryptography. So yeah, that's that. The next unique, service or the unique idea of Catalyst Network is the idea of public and confidential transactions working in the same network and the same ledger. So we will have fully public transactions, obviously where you can see the amounts, but also this idea of confidential transactions, which will hide the value. Yeah. So yeah, that's been a lot of work has been done on that by the Atlas City research team, which is on our GitHub, I believe. I think it might be open source, the Rust libraries, so you can go and check them out at any time. So we talked about this idea of probabilistic consensus. There's a kind of, I don't really see many projects that are kind of doing this idea. It's kind of a new idea. It's a it's a very new idea, and the way that we implement this idea is very unique to our project. So a probabilistic consensus is the idea that it's compared to more traditional consensuses like proof of work, which are a competition essentially, where nodes compete against each other, and in proof of work they're competing against each other to find an arbitrary hash, solve an arbitrary cryptographic puzzle that allows them to produce a new block. And that collaboration really does nothing for the throughput of the network. I mean, it does add a lot of security, but these nodes are expending massive amounts of energy on doing pointless work. So what we didn't really agree with that idea or that philosophy. And the consensus that we built is what we call a collaborative process, where nodes, they have to all come to a common agreement on a set of transactions to validate. And they validate them transactions, and they then produce what we call a ledger state update. And this ledger state update is then broadcast to the rest of the network, that then tell them, what the account changes, what the account differences are, the balances. This is appended into their own local ledger. Yeah. Okay. So, kind of just going more deeply into that flow. What we have here, sorry, is the catalyst transaction. When a node wants to make when they want to make a transaction on the network, this is the kind of object that will be produced. This has been defined again on the Catalyst GitHub. That's on an open repository at the moment, which is a Catalyst protocol protobus repository. So when a node or a person, user is wanting to create a transaction, the node will build a message that looks a little bit like this. And maybe we'll just go through some of this. So a protocol message, which is kind of this outer square, which contains all this information, is kind of like the packet on our network. So this has some routing information, so who it came from, a correlation ID that nodes can marry up that this correlation ID is for this message. The actual type of message it is itself. In this case, this is a transaction message, and the signature of the entire message itself. So the actual transaction that a node would create and broadcast to send some money to someone or call a smart contract is this transaction message. This transaction message is made up of multiple entries, what we call entries, and this is kind of a different take. Well, it's not the UTXO model. So Catalyst is an account-based ledger. So entries are usually denote a negative balance from an account and a positive balance from an account, a positive gap balance to an account. So if I was to send 10 tokens to Darren, I would, on a public transaction, I would do one entry of -10 for my account and one entry of +10 to Darren's account. So if you see here, this is what the actual public entry looks like. So here, the amount would be a -10, so debiting for mine, and +10. Well, there'll be one entry, sorry, for a -10, and then the to Darren address and from my address. And then this actual transaction message is again signed, which is a signature from all of the entries. And then this transaction is it's broadcasted to the network. When it's broadcast to the network, it's just a very kind of standard gossip protocol. I don't think there's too much to go into there. So they're all kind of very similar. So that's kind of very standard so far. in terms of what a consensus, how a consensus cycle or the user journey or user cycle of the consensus. You create a transaction and you broadcast it. And this is where the idea of the catalyst consensus starts to get a little bit more unique. So in traditional kind of like, I guess, Bitcoin, when you're filling up your mempool, or a node is receiving transactions on a network and it fills up its mempool, it just sticks the transactions in there, no specific order. It's kind of just like a dumb storage mechanism. And that is because, again, of how the POW consensus works, where only people who have been found the answer to this cryptographic puzzle are allowed to append a block. And at that point, they can choose what transactions they want to put into that block. It's kind of really, if you think about it, it's a bit of a silly idea. I mean, there's been lots of cases in Bitcoin where selfish mining, where people are deliberately holding back transactions from a block to push transaction fees up, clog the network for various other reasons, because they don't agree with something that the community are doing, etc. So in the catalyst idea of the mempool, we call it a deterministic mempool. And the reason why it should be a deterministic mempool is that everyone in the network should, like we said earlier, be coming to a common set of transactions which they need to validate within a cycle. And the only way that you can do that is to have a network-wide agreement on how you're going to process these transactions. So it's not, again, an overly complex algorithm that goes into it. We essentially just sort them in the mempool. First, we sort by highest amount. So you can see here in the little table, highest amount is 10. So obviously number 1. Next, we've got 2 transactions that came in that have the same amount, but the fees are different. So this guy got in a 3 token fee, and this guy got in a 2 token fee. Now, as I'm reading this, I realised I missed off a column for the oldest timestamp. But again, the oldest timestamp is that the transaction that has been the oldest sat in the mempool would obviously be the higher ordered. This one I did put in, which is a signature. Then the next step is, if you do have transactions with the same amount and the same fee, it just goes on the alphabetical order of the signature, so A and B. I guess before anyone says it, what if people don't receive all the same transactions? They won't ever get into the same order. That is true, but the kind of tests that we've done on the gossip protocol leads it to be a very small percentage of the network that don't actually receive all the transactions, which is accounted for later on. So now a node has its mempool and it's ordered the transactions, and it knows what common set that it wants to try and validate and produce into the next legislative update. So now we're going to talk about how that validation actually works. In the network, there's a network is a collection of nodes communicating with each other. But on our network, the nodes have 4 states that they can be in at any one time. And them states are a passive node. So that is just a node that is just connected to the network. You could call him he's a network observer. He can receive Delta updates and sync his global state with the rest of the network. He can broadcast transactions, and the node can also gossip, further, propagate existing transactions around the network. That node can also access and interact with the services that we talked about earlier on the Catalyst network. So stuff like the DFS marketplace, you can purchase DNS domain names, purchase compute. Yeah, but he's just passive. He's not doing anything to the actual validation cycle. So the next state a node could be in is what we call a reservist state, or a reservist node, sorry. And this is a node that has signaled that he wants to now become a validator, or he wants admission into what we call the validation or the worker pool. So there's a mechanism that's being discussed about how that works, how the nodes actually get that admission to the pool. But anyway, he's signaling that he wants, his intent of wanting to enter that validation pool. So now that mechanism has worked and gone through, and the worker node is, and that reservist node has now become a worker node. That worker node is inside of what we call the validation pool. And that validation pool, once that node is in that validation pool, it's essentially eligible to produce deltas, but it doesn't necessarily mean that he will be producing, or that node will be producing a delta. And this is where the probabilistic nature of the consensus really comes in, because once you're in that network and you're in that pool, you're not. This is not like in DPoS or these kind of things where it's a leader election. You're not just, once you're in that validation pool, you're not actually validating. You're eligible to. So I waffled, but the next state is the producer node, and the worker node is essentially, workers from that pool are selected at random to become a producer, and this is done on a producer selection algorithm. Again, kind of a simple mechanism on how we actually select nodes from that pool. So every node on the network has what we call a peer identifier. That peer identifier is made up of public key of the node, the IP, and the port. So how worker nodes are selected from the pool to become validators is that during the cycles we produce state updates, and then state updates are stored on the DFS. The DFS produces a hash of that content, and you can look up that hash content on the DFS network. So using that hash, which is like a pseudo random network constant, we take an XOR distance metric to peer IDs of nodes that are in that validation pool. Depending on the size and ratio, the size of the network and the ratio of the pool, X number of closest nodes on the network can be selected to be what we call the producer node. And that producer node is the nodes who are actually voting on the next state update. So they're the guys who are actually taking the transactions from the mempool, from that deterministic mempool in order, and checking them against the state tree. Say, right, yeah, this account does have 10 tokens that can be minus from it, and this account can receive them. It could discard invalid transactions. But what should happen is they should come to, again, another common set of valid transactions that produce a state difference. So let's, in terms of the entire network constitution, just going back over them 4 states, we talked about the passive node, and that's going to be essentially the largest constitution in the network. They're just nodes observing and being a part of the network. The next stage, or the next state we talked about is a reservist node. And these are, again, the people who are in that queue waiting to become in the validation pool. The worker nodes, which are the people who are in that pool. And the size of that pool is dictated by the rest of the network size. And then we talked about the producer nodes, and they're the nodes who are actually going to be doing that next diff, the next cycle. So that worker pool, keep on talking about ratios. That's kind of important because of the, that is the whole basis of the consensus. So this worker pool contains nodes. It's kind of like an abstract view, but just kind of roll with it a little bit. Once you become out of reservist and you're in this worker pool, you're in here. And what we talked about is random subsets of them being chosen to produce the next ledger. So each cycle, random nodes will be selected and they can produce that next update. And in an ideal world, that's perfect, but there's evil nodes and bad people in the world. So what happens then? So let's say this is our worker pool and we have some bad people in there and they're not following the protocol, they're trying to double spend. Based on the nature of how the nodes are selected from random, we've done a lot of research on the probability of the 51% attack in this kind of like probabilistic nature. Depending, it all, like I say, is all done on the ratio and the sizes of the network constitution. So how many, how big is your network? How big then does your producer pool need to be to give you a certain level of confidence that there's not been so many bad nodes that are selected that can pollute the entire validation cycle? So yeah, we think we've got that ratio pretty well covered and well worked out. Obviously, in this scenario that there's just too many bad nodes and that ratio is completely wrong, then the validation pool could be polluted. But I think what one of our researchers, Joe, was telling me yesterday, I think it was like 0.1%. Joe could probably like back me up, or Pauline will say if I'm wrong, but 0.1% probability on an 8,000 network with a 800 node producer pool, and with 40% of that pool being bad nodes. But in the unlikely case that someone does double spend, they can pollute it. It's a double spend, and sad banana. Anyway, that attack research will be available to people who are in our EAP program. I'll talk a bit more about the EAP program later on and how to sign up for that. What essentially that is we'll be inviting people, or anyone can, is really welcome. I just want to like gate it a little bit. But anyone's welcome to come and start having a look through the research papers, start having a look through the code, start looking through the libraries. If you want to contribute, or you have some ideas, or you want to do something new, just let us know. Anyway, so we just talked about the worker pool and that probabilistic nature and the constitution of and the fabric of the nodes on the network. But we was talking about ledger cycles and how it switches around. But what is a ledger cycle? What do the ledger cycles look like? Sorry. So we said that producers validate common set of transactions from the mempool, and each producer compiles a state delta and votes. Every node, in that producer pool, build a state delta, and then they vote within that producer pool for the most common appearing delta. So again, say you've got 1,000 nodes in that producer pool, and 99% of them have received the same number of transactions in their mempool. We said a bit earlier on that the gossip protocol isn't 100% efficient. 99% of them are working on a common set of transactions. If they all are in agreement and they're all good nodes and they're all following the protocol, the delta and the difference of the state that they produce hashed should all come to the same hash. You hash a piece of content or a byte string or bytes, the same bytes, they should always come out to the same hash. So the nodes in this ledger cycle, or the producers, I say, in this ledger cycle, they validate the state and they produce the update delta. And by putting that on the DFS, what they actually do is they create a content hash link. That is then broadcast to its peers in the producer pool, and they essentially build like a histogram of votes. And the most common vote in there, is a bit more to it, but the most common vote essentially on the new update de facto is now the new state update. It's come to an agreement that this is what it is. That state update is broadcast. I'm going to talk about that in a sec. Sorry. Anyway, yeah. So what we've actually gone through so far in this slide is kind of this idea. This is in the consensus paper that is on the website. So creating transactions, forwarding producers, collecting the ledger cycle. Yeah. So when they vote on this state update and they've come to an agreement on what it is, they produce this delta. This delta links to the previous delta DFS hash. This delta contains the global account state tree. So that's the state of all the accounts on the network. This is essentially a diff from the last delta. So we're not including transactions in this. It's not necessarily a block like in a blockchain. We're not a blockchain, apparently. We're a DLT. So yeah, it doesn't contain transactions, but it just contains the diff between the accounts. This receipt tree is part of the KVM. So these are the receipts for smart contract transactions. Yeah, and once that comes to an agreement on that new from the producers, this is then broadcast to the rest of the network. The rest of the network pull it in, and they apply their state update, and then they're in sync with the rest of the network. So yeah, not a blockchain, delta chain. I don't know. Not a DLT, not a blockchain though. DLT. That consensus research is available on the Catalyst website as well. So this is produced by the research team, and I'm going to make simple slides out of it. So yeah, this is what we kind of went through and talked about, the construction of the nodes taken from the mempool, producing that update, voting for it, well, broadcasting that to the other producers, voting on it, producing the global update, and then synchronizing it back to the network. And at that point, yeah, the existing nodes in the network can then take out also them transactions in that update, so they're not going to try and reprocess them again. Okay, so I've missing a slide. So how are we doing on time? 40 minutes. How's everyone doing? Are they good? I don't know how to. How are you doing?
Yeah, good thing.
So, has anyone? I think we're going to do a Q&A at the end. I don't know if anyone wants to do it now or what.
Yes, Sam asked earlier about reviewing the bulletproofs. I'm not sure if Joe Kearney could jump in on that one, or whether you know much about it.
Yeah, of course. So with the can you hear me all right?
Yeah.
Yeah. So with the bulletproofs, we're looking into academics at the moment to actually go through all of our research, because within the department, I think it's quite. I think when you're working on a project, it's quite easy to get blindsided and get convinced that your ideas are working. So we are mathematically secure. So what we're going to do is, I think at some point we're going to go to myself and Pauline are going to go to our contacts that we've got within universities and get the ideas checked, because if this, I mean, fairly obviously, if this part of the protocol goes wrong, then we're going to have some serious issues. So it needs to be mathematically checked by, so there'll be academic professors checking their work for us.
Cool. I'm not sure. Is Sam Dare here, or not sure?
I think he might. I don't think he is at the moment.
Yeah.
Everyone's
welcome to more eyes on things on the open source community side. It's obviously the best. The more eyeballs, the better. So that's kind of like the consensus part of things. We've got another part of the deck which is the architecture of the actual node itself. So yeah, this is a bit more codey and a bit more techy. So we talked at the start about the modular architecture and the flexibility that it brings to the Catalyst network itself. So I kind of just want to go through all them different layers and familiarize people with them. Yeah, so on the very base layer, what we have is the Catalyst protocol itself. That's kind of like the intangible set of rules that we say. If I say hi to you like this, you say hello back to me in that way. Yeah. In the protocol itself, maybe I'll switch through a little bit on GitHub and the actual slides. All of these are actually defined in a language called protobus, and protobus is a serialization format that was developed by Google. Faster, smaller, quicker, all them kind of like cool things, but it's just an abstract, it's just more of an abstract format of, you know, what these objects that go into the across the wire or share between different SDKs and clients. So we talked about the protocol message earlier on. This is actually defined in here in this project. And the good thing about doing it in the abstract protobus is that, again, Google is super smart and figured out a way to then make that work in, well, compile it into several different languages. So what we do with that is produce SDKs. So here's just some like ones that we have. Just do JavaScript, Ruby, Python, all that kind of stuff. C#, .NET Core, those guys. So yeah, these abstract definitions generate these different protocols. Okay, sorry. The next step up in this architecture is the core lib. Core lib. Yeah, core lib. I think go through it in a sec. Core lib is core set of libraries. What slide? Why am I doing that? Oh yeah, I do. Abstract serialization format, language interoperability. This is what I was just talking about. Protocol SDKs, auto-generated building blocks for low-level functionality. Catalyst core lib, libraries and helpers for kind of like very low-level I/O operations, interaction with file system, interaction with databases, network, transmission and communication. But also kind of then provide the configuration base for the rest of the node. The next step up in that modular architecture was the Catalyst core modules. The Catalyst core modules provide, core module functionality. The core lib is more of a general library. It's obviously very specific to the Catalyst network and the blockchain in general, but it's a bit more. It's a bit more general. And core modules provide a lot more in detailed or a lot more specific functionality for a node. Core modules. These are our core modules that we are actively developing at the moment. You'll see things that we've talked about before. KVM, Catalyst Virtual Machine, that's a core module. Consensus is a core module. More on that one in a sec. A ledger module, mempool module, key sign, key store, etc., etc. These are provided as a core framework. Sorry, 2 seconds. So these provide that modular flexibility. These don't completely separated. They don't rely on each other in this like horizontal fashion. They all rely on core lib, but they're completely independent and can function independent of each other. So, you know, if you want to don't like how we did the mempool, go and take this guy out, and you can rebuild him how you want to. Yeah. Good thing about these modules as well is that yeah, you can start to use common, familiar functionality. So we talked about easing that adoption. If you're very comfortable in using a specific kind of technology for key value stores, you can extend this mempool module and use memcached or use Redis or use whatever you've already using a key vault in Azure or AWS equivalent. We use a local file system for our core one, but you can extend that and change it to do whichever one you like. Extending core functionality. Yeah. So yeah, custom functionality is the next layer. So what we do, or what we're building, is really that core layer of the code base. The idea of these optional modules, or custom modules, can be demonstrated in a particular node configuration that we're working on at the moment. This will be going in a public testnet in the next month or two. So, like I say, you don't have to use all the core modules. You see all of these ones that we have KVM and etc. In the first node that we'll be launching, we'll be taking a mix of them core modules. So we still have the ledger, etc. mempool. The first node that we'll be launching is a Catalyst node POA, the Community Edition. So we talked about optional modules. This was kind of POA consensus. The POA consensus kind of extends from our core consensus mechanism, which is the Delta production and voting, which I talked about a minute ago. The POA consensus just has a slight variation where it doesn't have that mechanism of worker pool. It is, you don't have a reservist node. It can't signal to become a validator. On the POA consensus, all the Delta production stuff and the voting is the same, but it's just an authority network, so you can select nodes, or there's a pre-selection of nodes. It's very simple at the moment, but I mean, what you can do is you can eventually, we imagine people being able to vote into a quorum, new nodes, etc. But this is an extension of the core consensus, so this is kind of like demonstrating this flexibility nature of the node. And POA discovery, again, it's just a bit of a demonstration rather than what we have on the main node code base, which is Hastings discovery walk. This POA discovery just takes a config file at the moment. Actually, it's kind of very simple. What we're building towards is the Community Edition, the full Catalyst node Community Edition. So again, the core modules, all of the core modules are present in this one. Like I say, we're steaming through with the KVM build at the moment. The full node, though, will have these additional services and these additional optional services. So we talked about the compute system. Not every node needs to do compute work, but if you want to do compute work, or you have a special high-powered node that you want to dedicate to compute, you might want to take the compute module. The Web3 module is kind of a bit more of a gateway into the DFS. So Web3 module will again be backwards compatible with the Truffle and kind of Ethereum ecosystem. But what we'll also be able to do is people who want to, provide dApps, there'll be kind of a vision that you'll deploy a dApp onto the DFS, and that Web3 module will be able to serve that to the public. So no more having to try and find kind of gateway servers. You can just run your node and have instant access on your machine to the entirety of the Catalyst network and on the distributed web, and also the distributed DNS as well. These are just the example of these optional services that you can mix and match into your node. But core modules are core, and that's core functionality that needs to be there. So, hey, have I got an old version of the slides? I have. So I push it up. Sorry, I had an old version. This is what we went through. There's just a few things that Thomas had that, you know, this idea of KVM, we've talked about it briefly earlier on, how it is an extension of EVM. But there's a few things, you know, maybe we can clear up on this. So the backwards compatibility of the ERC20. The Ethereum, obviously the EVM on Ethereum is quite popular with the DeFi community as well. You know, we'll have that backwards compatibility. So existing stuff like MakerDAO and existing stuff that are suitable for this kind of tech can be run on KVM as well. Backwards compatibility, again, with all existing like Solidity tools, Truffle, you know, Web3 API, and we're doing the backwards compatibility JSON RPC calls for interacting with the state. But this is where, you know, when I was kind of joking that what EVM wishes it could be, is all this kind of additional stuff. So yeah, this, you know, hooking into these core native services that Catalyst provides. So actually being able to use smart contracts that can build a DFS marketplace where you can buy and sell storage, and you know, you want to access these native like cryptographic functions that we have. The KVM covers all of this space functionality. Yeah. So oh yeah, so this is the thing that a lot of the Ethereum community are really kind of wanting in the EVM, but it's very hard for them to try and get it in there. Luckily, because we're starting from like kind of like scratch, that we have that, you know, kind of that benefit of the hindsight in reality, that we know everything that's wrong with the EVM, so that we can actually fix it all and do it, you know, an actual good version of it. So this idea of state rent to avoid the bloat, where smart contracts themselves will pay for their own right to be in the global state of the network, and once your payments are up and you stop paying, you'll be evicted from that state. Because you know, at the moment the EVM, yeah, you deploy smart contracts and it's stuck there forever. So yeah, there's that. So this is the end of the decks, really. I touched upon it briefly a sec ago, but we are early access program, or actively looking for people in early access program. Go to the Catalyst Net website /EAP and just sign up. We'll get in touch with you. But it's pretty open to everyone. And thanks, yeah. So these are handles, Twitter, GitHub, and mine as well. Come follow us. Things are starting to get more open source, but I think we're going to probably do another one of these in a month's time, or roughly a month, which will be open sourcing. And the person who is going to be helping us with that open sourcing is Mr. Richard. Hi, Richard.
Hello, how's it going?
I just wanted to introduce you. So yeah, Richard's kind of met Richard at Web3 in Berlin. Kept on seeing his name everywhere on GitHub. Contributes to all these projects and all these cool ideas. So we had to work with him. We hunted him down and talked to him about Catalyst. But yeah, he'll be our like go-to guy for the community. So yeah, maybe you want to say hello, Richard.
I don't know, that was really nice. Yeah, looking forward to working here. Should be fun. Forward to helping out. This is a pretty good presentation already, and there's already some community stuff online, so thanks, Anish. I don't want to take up too much time because I haven't done anything yet, but be around. That's it.
Awesome. Well, I was going to run through doing a node, but I'm quite conscious that it's already an hour. There's 3 nodes running. These are the POA nodes running. I mean, I think maybe in the next one that we'll go through a little bit more of this and actually do this kind of deep dive into actually setting it up. I was trying to see, because I know you get the logs of the phases in the Delta production cycle. I just want to see if you can see it, but maybe we can't. Not sure. Okay, anyway. Maybe we should open it up. Has anyone got questions? Or I'm getting my cue cards from Chris. Blockchain Live, which is next Wednesday. Yeah, he didn't say no. So yeah, it's next Wednesday. I'll be doing a talk. I'll be kind of doing this presentation again, but better. And I'll also be doing another developer den, which is going to be showing off these optional modules, which is going to be building Twitter on the Catalyst network. So, you know, Jack Dorsey the guy who made Twitter got his account hacked. It's kind of funny. So we're going to present an idea to him that maybe won't get hacked again. Maybe we want to buy Atlas City for lots of money. I'm not sure. But yeah, we'll be there. Chris will be doing a keynote as well. We'll have a booth and we'll have all the team there. So you can come and say hi. But yeah, I mean, is there any questions from anyone?
I think we had the question on the bulletproof implementation.
That's been answered.
Sam, which was answered by Joe.
Yeah, I just wanted to add, I mean, thank you, James, for that presentation as well. It's been really a good presentation, very informative. I just wanted to add actually that it's important to recognise that what's being built here isn't just a traditional blockchain where what we're trying to do is store structured data in a distributed ledger. Fundamentally, we came at this from the perspective of trying to support Web3 style of applications, and anyone who works in web microservices and web services in general, to have a successful web service, you need different kinds. You need different components to it. You need, of course, typically your structured data. So you have real data, which is what just DLT is great for, and blockchain is great for, that kind of data. But reality is you also need unstructured data, so videos, pictures, batch files. So this is why it's so important to have those kind of DFS components supported. And with microservices, you need to be able to run real business logic and quite complex logic. So what we're trying to do, I think, is encourage just a wider adoption of these kind of Web3 services. And as James mentioned, it's removing barriers to entry. So when I get involved in hackathons and such, I find it very frustrating to see just how people struggle to build applications on blockchains. Even something like Ethereum, it's been around for a while, but you see people struggling for days at a time in some cases to do the very basics. And if you compare that to where in the engineering community we're at, say in the cloud computing world, where people are just used to being able to fire up Visual Studio, build applications, deploy, and be up and running literally within minutes. Blockchain's a world away from that. So what we're trying to do is sort of extend the conversation a little bit, say, yeah, blockchain is really important, and it's such that it opens up so much potential. But if it's to really reach mainstream adoption, we've got to remove those barriers to entry. We've got to actually start to engage with not just computer scientists, but engineers and engineering teams. And we've got to start putting more attention to integration and supporting good design principles. And that comes with stacks. That comes with building actual stacks of technologies. And it's not just about Atlas City or any business or any team. This is very much a community project. And this is all about the community coming together, whether it's the IPFS community, whether it's the Ethereum community, any community, anybody to come in and start to build modules. And I think that's quite an important difference as well, this modular approach, because I'm personally not a big fan of just constant forking, because that can dilute technology. If we had the Linux kernel being forked into hundreds of Linux kernels, I'm not sure how Linux would be today. There's valid reasons to fork, and I think it's good for people to fork for experimentation and to fork when it's appropriate, but it's also good for people to pop back into a common repository. And I think this is something this would really encourage, this modular approach. People can develop modules, put it back into a common repository. People can create their own distributions, their own networks, their own code bases, and they can benefit from what everybody else is doing. I find it very exciting, this whole approach. There's a lot of differences just to the overall approach.
I mean, we've already, working with Thomas, the Nevermind team, we've already done, post pullbacks, commits back into their Ethereum clients. So I mean, they've contributed to our code, and we've contributed to that code, and it's a two-way benefit, right? You might be competing ideas or competing projects, but ultimately the all of them do get better from, or do improve from this kind of like collaboration process.
Blockchain Live's coming up, as you mentioned, so that'll be a great point. Also, all the social media channels. I think there's people in all social media, particularly Telegram, are in there daily, and also Twitter.
Yeah.
To ask questions. And
cool. Awesome. Yeah. Well, I think if that's the end of the questions, I know Sam had a question, which was reviewing bulletproof implementations, and I know why he asked, because Sam Dare is going to be reviewing it, so I'll send it back to him. I'll give him the access. Anyway, he needs to sign up to EAP/EAP. But yeah, right, guys. I think we'll call it. Thanks everyone for attending, and we'll see you on the next one. Bye.